Hello and welcome, my people. Guten Tag for another video lesson. I'm Mr. Kozad. This is 8.1 for Algebra 2, multiplying and dividing rational expressions. Thank you for joining me. We're going to have a lot of fun. So today, what you need in front of you is a sheet of paper, okay, and you're going to take notes through this. As always, fast forward, rewind, pause, stop and come back later, however you need to pace yourself. But this will walk you through not everything, but some of the basics for section 8.1 in our Algebra 2 book on multiplying and dividing rational expressions. Okay, so in our first particular example here, kind of the first techniques you want to always use on every single one of these problems is factor first. Okay, factor first. So if you have not written this down yet, pause it now, write this down, and then click play when you're ready for me to talk through this. Okay. So factoring first means we take everything in the numerator and everything in the denominator and we try to factor it as completely as possible. Okay, so let's see what that would look like with this particular problem. So the numerator, what I see here is I see I have a 4y. That's fine. We don't need to change that at all. But I also have this trinomial. Now maybe one of the hardest parts of this section is going to be remembering how to factor. Okay, so this factoring could be a lot more difficult than it is because my lead coefficient here is a 1. And if you remember from Algebra 1 and then again earlier in Algebra 2, factoring when your lead coefficient is 1 is super easy. You're looking for two numbers that multiply to give you negative 12 and add up to give you 1. So in this particular case, it should be plus 4 minus 3. So we'll factor that to y plus 4 times y minus 3. So we have factored our numerator correctly, completely. So then we'll take our denominator. Now the first thing I see in the denominator is there is a GCF on these three terms. I can start here by factoring out a y. When I do that, I have y squared minus y minus 6 left over. And then I've got a trinomial here that I can factor further, potentially. Okay, so I want to see how this trinomial factors. Two numbers that multiply to give me negative 6 that add up to give me negative 1. Okay, think about what those would be. And you could say it out loud if you want. It's okay. It's not awkward. Did you say it out loud? Good for you. So let's see if you got it right. So our numerator hasn't changed at all. We've got that y that we factored out. And two numbers that multiply to give us negative 6 and add up to give us negative 1 are minus 3 plus 2. So that's going to be y minus 3 times y plus 2. So at this point, we've done all the heavy lifting. Okay, we've got the top and the bottom factored completely. And then our second hint here is to find like terms to eliminate. Now, what is a like term? A like term is an expression that is exactly the same as another expression. So for example, if you look at the top and the bottom of this fraction, we see that we have a y minus 3 on the top and we have a y minus 3 on the bottom. Those factors will actually cancel each other out. Okay? I also see that I have a standalone y right here and a standalone y on the top. Those y's will cancel out. Okay? So we've eliminated our like terms, and then the last thing you have to do is put it all together with what you have left over. So on the top we have 4 times y plus 4, and on the bottom we have y plus 2 left over. That would be your final answer. Now in this class, the nice thing about this section is you are very rarely going to have to multiply anything back out. So for example, your numerator you could leave as 4 times the quantity y plus 4. If you feel better multiplying by 4, that's fine, but you'll see in a few problems later that it's actually going to be a lot easier for you to just leave it in factored form like this. Okay. Now, this last question here on this particular example is super critical, not so much for 8.1, but this is going to be a really important question to answer as we get further in Chapter 8. Okay? What values of y make the expression undefined? Well, in order to do that, you've got to understand what does it mean for a fraction to be undefined. Okay? A fraction is undefined when your denominator is 0. When your denominator is 0. So really, this is another way of asking you which y values make the denominator equal to 0. And to do that, what we're going to go to is we're going to go up here to the form that we had when it was completely factored, when it was factored completely. So let me rewrite that without canceling anything. So that was 4y times y plus 4 times y minus 3 all over y times y minus 3 times y plus 2. Again, that was the factored form before we did any canceling. Okay? So then we just talked about this, that any y value that makes the denominator equal to 0 makes this expression undefined. So what we're going to look at here is we're going to look at the denominator specifically, and we're going to ask ourselves, what y values can we think of that make this denominator 0? So in other words, we're looking at all of these factors, what makes each one of those individually 0. Okay, so our three y values that are off limits here are 0, positive 3, and negative 2. If I use any one of those zeros, one of the factors in the denominator would be 0. And if you multiply anything by 0, you get 0 as your product. So if I use 0, 3, or negative 2, any one of those three y values, plug it in the denominator, that denominator will end up being a 0, which would make this expression undefined. Okay, so we would say the three values for y that are off limits are 0, 3, and negative 2. Those are the three y values that make this expression undefined. Again, log that to your memory. That's going to be a really important skill the later that we get in Chapter 8. Okay, so let's move on to the next one. Okay, here's another problem, number 2. So take a second wherever you're at and write this down. Okay, if you need to pause it, that's fine. I'm going to kind of jump right in and go. The same strategy works here as worked in the last problem. We want to factor the top and the bottom as completely as we can. Okay, so as I look at the top here, I'm looking for a GCF, and I can see those two terms do in fact have a GCF. They both have an A and a B in common. So if we factor that out, we factor out an AB, what we have left over is we have B minus 5 on the top. And if you're not sure about that, a good way to check yourself is you can always go backwards and actually multiply this out. And if you did it correctly, you should get back to AB squared minus 5AB. Okay? Now the bottom is going to be, to know how to factor that means you're going to have to remember how to handle a difference of squares. Okay? Is 25 a perfect square? Yes. Is it a difference? Yes. Is B squared also a perfect squared? Yes. So what we have here is we have a difference of squares, which we know from Algebra 1 and then again from Algebra 2, that we can factor that in a unique way. It's going to factor to 5 plus B times 5 minus B. Just a factor, difference of squares. Again, you've learned that before. It's up in your brain somewhere. Okay, so now we step back and we look for any terms that we have on the top and the bottom that can cancel each other out. And I don't necessarily see one explicitly that can factor out, but this one looks really close. B minus 5 and 5 minus B. So that's why I give you that trick. We can actually factor out a negative 1 to get those factors to be the same. Let me show you what I mean. Okay, so we're going to leave the top alone, AB times B minus 5. And what we're going to do is we're going to take a negative 1, and we're going to factor out a negative 1 from this second term on the bottom. So if I do that, if I factor out a negative 1, I end up getting negative 5 plus B, if I factor out that negative 1 correctly. And as you can see, we can change the order of negative 5 plus B. We can rewrite that as B minus 5. So I'm going to slide the negative 1 out in the front. I'll keep the 5 plus B, and I'll change that to B minus 5. So now you can pretty clearly see that you've got a B minus 5 on the top and the bottom that cancel each other out. And what we have left over here is we have AB on the top over negative 1 times B plus 5. Now, one mistake that people will want to make, or maybe you're thinking yourself too, is, well, Cozad, we see a B on the bottom and a B on the top. The problem with this B on the bottom, and the reason why you can't cancel it with the B on the top, is because this B is part of a addition problem. And if you want to cancel this B, you have to cancel the entire term, which means you'd have to have a B plus 5 in the numerator in order to cancel that. Okay? So you could leave your answer like this, or you could slide that negative into the front, or I'm sorry, up to the top. Let me erase that. Oh my goodness. So you can slide that negative into onto the numerator if you wanted to write it this way. Or if you wanted to, you can leave the negative on the bottom and just distribute it out. So it'd be negative b minus 5. 3 different answers that are all equivalent, and for my class would all get you equal points. Okay, so any of those answers would work. Okay, next problem. Now we're going to look at not so much simplifying expressions. We're going to look at how we multiply. So take a second, write this down, and then get back with me when you're ready to go through the problem. Okay, so the hint that you see here is that we want to factor first, then terms on top and terms on bottom cancel each other out. Okay, this is going to be kind of a unique way of multiplying fractions that may be a little confusing for you, and that's okay. You might have to watch this part a couple times to see exactly what we're doing here. Okay, so here's what I look at here. The first thing I see is there's really nothing that I can factor in any one of these numerators or denominators. They're all pretty good, pretty clean looking. Okay, so now what I'm looking for is I'm looking for anything in the denominator that would cancel something in the numerator. Okay, so the first denominator is 21b. Notice what you're looking for is you're looking for a b somewhere in the numerator that you can cancel. So this b and this b are going to cancel each other out. Okay. I don't see any other d's in the denominator. I also don't see any other c's in the numerator. So d squared and c squared are going to stay where they are. But we can actually apply the same concept to the numbers that you see here. So if you look at 21 and 14, okay, 21 and 14 are both divisible by 7. Okay, so if we divided those by 7, the 21 turns into a 3. The 14 would turn into a 2. Okay, and then if you look, we can take it even a step further. This 8 and the 12 are both divisible by 4. So I could cancel this 12. If I divide that by 4, it becomes a 3. And the 8 divided by 4 would become a 2. So now if I look at that even further, I see I have a 3 here and a 3 here that would cancel. And this 2 and this 2 cancel out as well. So then what we're done canceling. So now what we do is we just collect everything that's left over. And in my numerator, the only thing that's left over is d squared. And in my denominator, the only thing that I have left over is c squared. So that's d squared over c squared. D squared over c squared, final answer. Again, if that went pretty quick and you were a little confused on how we canceled those, go back and watch that again, and I think you'll pick up some things you missed the first time. Okay, division is super similar to multiplication because if you had a good Algebra 1 experience, really this even goes back to 7th and 8th grade math, when you learn how to divide fractions, you were probably told that dividing fractions, you keep the first, change, and flip the second. So keep the first fraction, change it to multiplication, and flip the numerator and denominator on the second fraction. If you had a good experience in your math history, you got that, okay? The actual mathematics term and what your teacher is going to want you to say is that when you divide fractions, it's the same as multiplying by the reciprocal. Okay, that's where your teacher's going to want, the language they're going to want you to use is multiplying by the reciprocal. Okay, so really what that means is we take the first fraction and we keep it the same. 12x to the fourth, y squared, all over 40, a to the fourth, b to the fourth. Now we're going to multiply by the reciprocal, so we change it to multiplication. And when we take the reciprocal, remember that's just taking the numerator and denominator and flipping them. So now what we've done is we've very quickly and easily changed this division problem into a multiplication problem. And it's just like the setup in our previous example. So now what you're going to do is scan your numerators and denominators, and you're looking for things that can cancel. Okay? So remember, the trick with canceling is it has to be numerator to denominator. You cannot cancel something that's in both numerators. Okay? So for example, I've got an x here and an x here in the numerator. Those do not cancel each other. It has to be top to bottom or bottom to top. Okay? So what I see here, let's go with the x first. So I've got an x to the fourth on the top and an x squared on the bottom. Okay? Well, this x squared is going to cancel not all of these x's. it's just going to change this x to the fourth to an x squared. It's going to drop it down by 2. Okay, same concept with the y's. This y squared is going to cancel 2 of the y's in the denominator. Okay, so then the next thing we can do is let's clean up our constants. So 6 and 12 are both divisible by 6. So 6 divided by 6, that changed that to a 1. 12 divided by 6 changes that to a 2. 40 and 16 are divisible by 8. So 40 divided by 8 would be 5. 16 divided by 8 would be 2. And the other thing that I see here is I've got an a squared, which is going to make this a squared in the bottom. So then we need to be a little bit more careful here to clean up everything we have. So in my numerator, I have a 2. I have a 2 times 2, which is going to be 4, times x. So my numerator, when I clean all this up, is 4x. Again, that was 2 times 2 times x. In my denominator, I have a 5, I have an a squared, and a b to the fourth, and a y squared. So I have a little bit more going on in the denominator. So we have 5, a squared, b to the fourth, y squared. Okay? And as you can see, there is nothing else left to simplify there, so that is my final answer. That's my final answer. So division is super simple, especially if you know how to multiply, because just remember, division, we change the problem to multiplying by the reciprocal. Okay, here's kind of an interesting application of division that you may not think about. It's something called a complex fraction. So again, if you need to pause and write this down, please do that. And then jump back in when you're ready to follow along with what I'm going to do here. Okay, so complex fractions. What a complex fraction is, it's a fraction within a fraction. So here, if you look at this, we have a fraction over another fraction. Okay? And you need to know, and you probably do know, that a fraction is another way to represent division. So basically what we're doing here is we're taking the top part and we're dividing it by the bottom part. Okay? So if I rewrite that, I have x minus 2 quantity squared all over 2 times x squared minus 5x plus 4 divided by x squared minus 4 over 4x minus 10. So we know from our previous example that we did that division, fraction division, is the same as multiplying by the reciprocal. So I'm going to take this as x minus 2 squared all over 2 times x squared minus 5x plus 4. And I'm going to multiply by the reciprocal. So I'm going to multiply by 4x minus 10 all over x squared minus 4. And you've turned this into a multiplication problem, just like we've done the last two examples. So what I'd like you to do is I'd like you to pause the video now, and I want you to try to factor this completely and see which terms cancel out and see if you can get the simplified answer by yourself. So pause it now and try this, and then turn it back on when you're ready to check your answer. Okay, hopefully you have paused and you're back with me, and I'm going to show you what it would look like as completely factored. Okay, so x minus 2, the quantity squared, I don't need to change anything with that. X squared minus 5x plus 4, two numbers that multiply to give me 4, positive 4, and add up to give me negative 5. That's x minus 4, or I'm sorry, x minus 1 times x minus 4 times, I'm going to factor out a 2 from 4x minus 10, so I get 2x minus 5 left over. That's all over difference of squares. You should have recognized that. We talked about it earlier today. X minus 2 times x plus 2. Okay, so then what we're looking for is we're scanning this to try to find any terms that cancel each other out. So you should have seen a 2 and a 2 that cancel. And then this x minus 2 doesn't cancel both of these. It just drops that exponent down to a 1. Okay? So then here's what you have left over. You have x minus 2 times 2x minus 5 all over x minus 1 times x minus 4 times x plus 2. Again, you can stop here as your answer. You do not need to multiply it out. In fact, my preference is for my class that you would not multiply it out. It's easier for me to grade, and it's easier for you if you leave it in factored form like this. Now, if we went back and I asked you that question that we asked at the very beginning of this lesson, which x values, this is a bonus question, which x values make this undefined? Okay, so which x values make this function undefined? Remember that you're looking at the x values that make the denominator equal to what? 0. Okay, so here there's going to be 3 x values that make the denominator 0. So x cannot be 1, x cannot be 4, x cannot be -2. Again, that is a really, really valuable skill that's going to help you the rest of the way in Chapter 8. Okay, so we just have one more thing for you to do. It's kind of a practice problem for you to try. I'd like you to try this. It is so spicy. Okay, hope you like spicy food. If not, go to the kitchen right now and get some milk. Milk helps cut through the spice. You can do it. Okay, so take a second, pause it now, see if you can do this. Factor everything completely. You've got a little multiplication, you've got a little division. You can do this. Try it now. Welcome back. Hopefully you actually took my advice and paused the video and got this done. Maybe some of you actually went to the fridge and got some milk. You're like, Kozad, this problem's pretty easy, but man, milk sounded good, so maybe you went to get some milk. Okay, so let me show you what this would be. Okay, I'm going to go through it, like I said, pretty quickly, assuming that you spend some time working on this yourself. Okay, so t squared minus 100, difference of squares. So that's t plus 10 times t minus 10. Don't you just love when t is the variable that we use? Okay, probably the majority of you are saying no, Kozad, we don't like that because it looks like a plus sign. Okay, we'll figure out a way to make it look better. Okay, so 4t squared, we'll leave that alone. Okay, the numerator here, I can do two things. I can factor out a t on the second numerator, and then I'm looking for two things that would multiply to give me negative 50 that add up to -5. So that's going to be t minus 10 times t plus 5 all over, factor out a t cubed, and we get t plus 10 on the denominator. Change the division to multiplication, so we're multiplying by the reciprocal, 5t over t minus 10, the quantity squared. All right, so now what we look for is we're looking for anything that cancels, so anything you see on the top and the bottom that can cancel each other out. Okay, so I see a t plus 10 and a t plus 10. Those will cancel. Remember, it doesn't matter which fraction you cancel it from. The only thing you have to remember is it can't be top and top. It's got to be top to bottom or bottom to top. So then I see a t minus 10 squared, but if you look at the numerator, notice how you have two t minus 10s? So you're actually going to cancel both of those, and it's going to take care of both of those in the denominator. Okay? So then I see that I have a t on the top and a second t on the top, so that's the same as t squared. So that's going to take care of the t squared on the denominator. Okay? And it looks like that is everything that we can cancel. So here, let's clean it all up. So in my numerator, I have 5 times t plus 5 all over 4 t cubed, if I got it all. Okay? And that, my people, is your final answer. Now again, please fight the temptation. You cannot take this t here and cancel a t on the bottom, because remember, this t on the top is part of an addition problem. So if you want to cancel it, it's all or nothing. That was our journey through 8.1. I hope you enjoyed it. Okay, there will be an assignment on your calendar that you should be able to complete. Please let me know if you have any questions. Have a great day.